available software, simulation software, then it's not easy to develop some unique output. So for this one, PV module output, we developed some unique equation to represent the power generation from PV modules. And for example, then verified by simulator. We have a solar simulator on 10th floor of this building. For this one, this previous one, in a block FJ block. And now we move to this block on 10th floor. We have solar simulator. We use pyranometer to measure solar radiation. We use IV curve tracker to measure the IV curves. We use a refrigerator to control the temperature under 25 degrees Celsius. Then we verify our simulation. Here I also mentioned that after simulation, or even theoretical analysis, we need to do experiments. Especially for my PhD students, I always encourage them to do experiments. If the simulation can be verified by experiments, it's very easy to publish your paper. I have been editor of Applied Energy for many years. It's very easy to accept some paper with experimental verification. You see, we simulate the performance of PV module. You see, a lot of variables. Then, I don't have time to show all of you. How to find this maximum point under different solar radiation, different temperature, and different external resistance? That's a problem. Then finally, we found that we can use so-called five parameter to represent the, let me see, it's here I think. Yeah. We propose our model with 5 parameters to represent, so that to calculate the power output. You see, the maximum power point can be calculated from the theoretical equation correctly, validated by experiments for any temperature, any solar radiation. Then we also validate our simulation by outside experiments. This is the only large project, not very large, on the rooftop of Y block. The university helped us to set up this experimental system, 22 kilowatts. It's still there, still working, but very limited power generation. I must say, PolyU is not very good for solar power generation. We have only limited capacity installed, not many, which is university in Hong Kong, USD, and CTU install a lot. You see, we did a lot of model validation through field measurements. Five variable simulation. This is the IV curve, this is the IP curve, VP curve, power generation curve. Then finally, we found that solar radiation plays the most important role for power generation. Solar radiation, of course. Ambient temperature as well, higher temperature, low efficiency, then cause module temperature could be 55.8 degrees Celsius. Very high temperature. If you touch the front surface, very hot. This is available solar radiation. At noon, sunny day, at noon, very good solar radiation. And we also have some simulation to predict solar radiation. Cloudy day, we can use the cloud index to predict solar radiation as well. Then we derived the equivalent model for solar cells power output. You see, original theory thinks that the current is a function of voltage itself, the voltage caused by temperature, and the resistance outside, very, very complicated. And then after simplification, we use 8 constant to represent the current. Then it's much easier. This 8 constant can be obtained from experiments. Then you say very accurate. I don't have time to show all of this. I just want to tell you, we can find the simplified simulation model. Nowadays, the model is still used by many authors. We have got many citations. This is, among the 3 models, we are the better one. Not the best, maybe the best one. I don't want to show you. Another study we did for the government. The government officer contact with us to say which panel should be used. Monocrystalline, polycrystalline, how to incline the panels. Facing south, what is the best inclination angle? So we did a lot of experiments for the government. Of course, we published a lot of papers as well. This one is existing project on the headquarters of EMSD, Electrical Mechanical Service Department of the government in Tuguawan. This one is Hong Kong Electric Company Limited to supply power to Hong Kong Island. This is power plant. In Hong Kong, we import nuclear power from Guangdong, but most of the power is generated in Hong Kong. We have 2 large power plants. One near Lam Island. This is Lam Island power plant. They install PV panel on the roof as well, but it's limited. Power generation is limited. So we compare different models' performance. We collect 5 different PV modules from 2 different manufacturers for each. Monocrystalline silicon, polycrystalline silicon, amorphous silicon, CIGS, and CDTE. These 5 different type of PV modules represent the main technologies. But monocrystalline silicon occupies 95% of the market. Then we set up an experimental system in the new territory. We bought 10 different PV panels from for 5 different types, each for 2 panels. We install optimizer for each panel and the inverter for all the system connect to the grid. Then we install a data collection system. This is a real project we install in the form of the new territory. 2 monocrystalline, 2 polycrystalline, 2 amorphous silicon, and 2 CIGS, 2 CDTE. If you want to know the Chinese name, this is called 单晶硅、多晶硅、非晶硅、地化格CIGS. Then we install the optimizer, inverter, and data collection system in its power plant. Plant room, not power plant, plant room. We measure solar radiation by pyromanometer, wind speed, even humidity, and temperature, of course. Temperature, humidity, and wind speed by anemometer, pyranometer for solar radiation. And this is daily energy output from the system. And we measure, of course, power output from different systems. We validate the simulation by experiment as well. And finally, we found that monocrystalline silicon is the best, has the highest energy efficiency, and performs the best out of the 10 test PV modules, followed by CDTE. So this one was produced by the first solar of the American manufacturer. Very good quality, but expensive, very expensive. That's why its market share is limited. Then, for sunny day, you can say which one is the best. Monocrystalline, followed by poly and CDTE. This is solar radiation, very good solar radiation. I think October, November, you see? At noon, nearly 1,000 watts per square meter. Started from 7 o'clock until 5 o'clock in the afternoon. Yeah. In October, November. You see, in Hong Kong we have so many cloudy days in spring, but we have very good sunshine in late summer and winter, autumn and winter. Now we have more cloudy days from now until May, June. So energy conversion efficiency, monocrystalline and followed by CDT, polycrystalline, CIGS, amorphous silicon. That's why amorphous silicon market share is less and less now. We only use amorphous silicon panel on a calculator, watch, indoor, small items. Nowadays, maybe mouse and keyboard, especially a calculator. Yeah. We use amorphous silicon because monocrystalline, polycrystalline, even CDTE cannot be used for indoor environment. No power generation. Cloudy day, same, similar. Monocrystalline, CDTE, polycrystalline, CIGS, amorphous silicon. Then we submit our report. We also got the power generation equation, which depends available solar radiation and temperature, even wind and humidity. But solar radiation and temperature represent the most impact variable. We got A, B, C, D constant. That means there are 4 variables for the power generation, which is very accurate for engineering use, not for theoretical analysis. So the variable means wind speed, ambient temperature, especially solar radiation. Enough. You may say, why wind speed is a factor? Because wind speed will change the solar panel temperature. Because higher wind speed and a higher convective coefficient, heat transfer coefficient between the panel surface and the air, lower, which causes lower temperature and then higher efficiency. Then we did another simulation for another project, a simulation of different BIPV facade of buildings. We want to integrate PV panel on the building facade, but how to calculate the output, that's a problem. So we derive this equation. We call it, Then this is error, very low compared with experiment, 8.23%, 10.7%. For engineering use, very low. Then we derive, we got the solution. You can see, this is for different tilt angle and different orientation, facing south, the best. Tilt angle, 22, 30, 20, 25%, this is the best, 20, tilt angle. That's a tilt angle between the panel surface and the horizontal surface. That's called tilt angle, or the slope. So the best tilt angle in Hong Kong is 20. Then the best orientation is 180 degree, that's facing south. So this is best. So that on the ideal power generation, we can get the most. Same, mono, poly, amorphous silicon, and similar. We provide this data to the government. We also publish some papers in this area. Then we did economical analysis as well. I must say, we have done most of our research are applied research. Next session, next week, I'll introduce another one, applied research as well. Ground source heat pumps. This result are very useful for the industry for engineering purpose. You may say, how about publication? Very good publication record, but not many paper for Nature. We have just published one paper in Nature Cities. We submit Nature Communication, but I must say, our work are mainly applied and research. We have a lot of publication in applied energy, energy conversion, renewable energy, even heat transfer communication, and so on. But not nature or science, you may say. My conclusion is that silicon base is the best, even in the future. Even discovered 70 years ago, silicon base is still the best. We developed simulation model and then verified by experiments. I encourage you to do experiments for your paper publication, for citation in the future as well. I just finished. First, sorry for late coming because of my mistake. If you have any question, you can ask me now or anytime by email. If you are interested in it. I must say most of you are not working in this area. You don't need to understand the details, I must say. You should just understand the fundamental, the concept. And for your final, we have an examination, not closed book examination. That's only oral interview, I think. We'll ask you some questions about the fundamentals, the questions. about fundamental principle, not the detailed equations. Don't worry about that. If you have any questions, you can contact with me by email, or you can go to my office directly. I'll see you next time. I will upload the recorded video later. Thank you.